So we now have talked about the problem of origins and the different accounts there are of the origins of the universe. And we've talked about the problem of structure, which seems to have fairly well been solved, that the structure of the universe is due to gravitational effects coming out of this very hot dense state. What about the end of the story? What about where the universe is going to end up? Well, when Einstein started to look at the theory of general relativity, he found that it gave you the possibility from this expanding state, it would slowly stop expanding because the gravitational attraction of all the galaxies on each other are opposing their tendency to move apart. The expansion would stop, and then they would all come back together into what's called a big crunch. So that was one possibility where the physical universe is going to end up. If there wasn't enough matter and enough gravitation to stop the expansion, there was the possibility that the expansion would simply go on forever. And the matter would become more and more separated, galaxies would become more and more separated from each other and thinned out. And astronomers were looking for clues to which of these scenarios would occur. The main number that you need to calculate is the overall density of matter in the universe. And when this was being calculated, it was found to be very, very close to the critical number that separates the closed universes that come back and crunch again from the open universes that expand forever. In the 1990s, astronomers found something unexpected and extraordinary. When they were looking at the most distant galaxies, what they found was that instead of their expansion rate slowing down, as you would expect, their expansion rate was speeding up. They seemed to be being pushed apart rather than drawn back together. And that has been, since the 1990s, verified. So there's got to be another element in play here than the ones we have so far. Ironically, it looks like exactly what's in play is Einstein's cosmological constant, this thing he added to his equations to try and make for a equilibrium world that doesn't change, has to be added back in to understand why the universe is expanding at an accelerating rate. This cosmological constant is sometimes called dark energy. So we have, in addition to visible matter that we're aware of, that we can see, the dark matter that we talked about before, and also dark energy. In fact, according to modern understanding of cosmology, visible matter that we're familiar with is maybe 5% of all the matter there is. Most of the universe is stuff we don't understand. But as long as we accept that there is this dark energy or this cosmological constant, it's clear how things end up. The universe will continue to expand and expand faster and faster. All of the galaxies will be separated out. All of the matter will get thinner and thinner and less dense. And the universe will go on getting colder and colder and less populated forever. So that's the end of our story. Of course, the religious accounts never end quite like that. They have a much more satisfying and decisive ending. Even the Hindu cyclical cosmology has a final cycle, which will be the end of all things. Of course, the Christian story has the judgment day and the end of the material world. So if we look to cosmology to find our place in nature, modern cosmology suggests that we don't have a particularly central role in things. We are living in the middle period of cosmos that is much older than originally was thought, that it has been existing for billions of years, that will continue to exist presumably forever. And we happen to be in this fertile period when there's enough structure to have planets and for life to evolve.